Hello friends, welcome back to the part 3 video in the series of water tank automation. So in the previous video, we have seen how to install ESPHome firmware into ESP01S microcontroller. In this video, we're going to discuss about two things. One is software related and second is hardware related. So the hardware part is building the relay circuit, the actual relay module, and also the power supply to the ESP01S microcontroller, everything into a 3D printing case. So that is hardware part of the video. And coming to software part, we're gonna use the onboard LED and turn it off using a HTTP post request. So we will send a HTTP post request to turn on and turn off onboard LED. So later we change this onboard LED GPIO to the relay module GPIO so that we can turn on and off the relay module using HTTP post request from this laptop. So this is what we are trying to achieve in this video. So my ESP01S is online, and if you see here, the motor controller is online. So let's start with controlling the onboard LED, which is a blue LED. So currently ESP01S is connected to Wi-Fi and also it's showing online in our ESPHome dashboard. But ESP01S is not serving any web page for us. So how would you know it's not serving? So if I click on visit, so it's trying to reach to this particular IP, but I'm seeing this site cannot be reached, error, right? So to enable a web server in this particular controller, you need to edit the config and add a key. So basically, you need to enable a web server in the configuration. So let's do that. So now I'm going here and under Cap2 portal, I'm just pasting this. So if you see here, I have added this web server with on port 80 and I'm clicking on save and I'm clicking on install. Since we're already connected to router and we are online, you can use wirelessly. This will take a while. After a while, you will see that successfully compiled and uploaded, and you will also see OTA successful message. So we can stop this now. Let's close this. And if you see here, motor controller is online. Click on visit. So now a website, a web page, something like this. You can directly update the ESP01S through this OTA update. You can choose the bin file and you can update. So let's add a light now. Go to edit. So first we need to define a GPIO pin as output. So let's do that. And I'm using pin 1. So the GPIO pin 1 in my ESP01S is connected to onboard LED. So I'm calling it as onboard LED. And now let's define a binary light. Copy and then paste it here. So now I'm calling this as onboard LED, and I'm defined the ID in the top. Use that ID here. Yep. So we're all set. So we had a light, and we are calling that light as onboard LED, and we attached a GPIO pin as output to this particular onboard LED light. Okay, so let's save and click on install and use wirelessly. Okay, now if you go to the web page again after the upload, you can see we see a new component called onboard LED. Currently the state is off, but if I see the LED, which is already started. Okay, so the LED we need to reverse the polarity on GPIO pin, but it should be fine. We can always reverse later. But so when I click on, LED is turned off. When I go back to off, LED is turned on, off, on, off. It is working reversely. We can just reverse the polarity. It should be fine. Okay, let's reverse the LED. So in the GPIO section, we need to add inverted equal to true. Click on save and install. Click on wirelessly. So update is done. Let's go back now. Let's refresh this page. So if you now see the controller, LED is off. I'm doing on. So LED is on now. Let me turn it off. So LED is off again. Let me do the on now. On, off. So now LED is working as we are expected. So next step is controlling this LED using a HTTP request. So ideally the HTTP request should work by default. We are already serving the web server. Along with the web server, there should be a REST API automatically added. By default, we can able to control the LED using a HTTP request. In order to control the light through HTTP request, we need to have an ID for the light. So let me do onboard LED light pin and change this here. This should be fine. Onboard LED. This looks much better. Let's do the saving and let's click on install wirelessly. So after the update, I am using Postman to send the HTTP request. So this is my Postman. I have two different requests created here. One is light on and light off. If you see light on, this is the URL. Basically, this is where the ESP device is running, and you will use light. This is standard default, and this is my light ID. So which is defined in the configuration. So and I am using turn on command. So if I now let's do this. This is my light. If I now click on send here, the light is on and I get a response 200. Okay. So in the same way, I have light off with the end command as light off. So I'm sending it. See, light turned off. So if I click and on light on, I'm sending it, light is on, and sending this light is off. So now we have validated that HTTP light control is working. Now let's move to the next part of the video, which is building the relay module. So before showing you the end module, which I prepared, I will show you the individual components and want to talk a little bit about those individual components. So this is the SMPS. So it will take AC input and gives you DC output. There won't be any polarity for AC. DC side, you will have the polarity. So there is a plus V, which is a 5 volt, and minus V, which is ground. So this side will go into your relay module, and this is the PCB. One suggestion while working with this PCB is after you inserted your component, always cut the extra PCB using the holes. Take a scissor and cut on top of holes. In that way, don't chip the PCB. Okay, so this is the PCB terminal block. Basically, you can your wires will go here, and you can tight the wires using these screws. Okay, let me keep this aside. So this is the final module at motor control side. So you will have this blue part is the relay module for ESP01S, and you have your power unit in this side. So this is the power part. So the output of the power SMPS, which is DC, is went into VCC and ground. If you see here, this is the AC input, and AC input I connected to a terminal block, this particular terminal block. So you need to plug in your AC, both the phases into this terminal block. Then this module gets its power, and its output will go into your relay module. Okay, so then the actual relay has two terminals. One is common and one is a disconnect terminal and a commonly connect terminal. When we don't supply power to relay, common will be connected to NC, which is like a normal common. But when you turn on the relay module, you will connect the common to the NO, normally open. So I am not taking NC, but if you want NC, you can just add it. There is this third terminal block. I don't have anything in this terminal block now. But if you want, you can add NC to one of the hole for the in the terminal block. And also maybe if you want the output of 5 volt and ground, you can also take that into this terminal block. Second terminal block is basically now common and your NO, which is normally open. Once relay is turned on, then only these two holes will get connected. And this PCB is attached to relay module. I just used a CA gum. Yeah, this is how it looks from the top angle, and this is how it looks from the back side. I will also make a 3D printed enclosure for this so that we can directly keep this behind the switchboard without worrying about these lines touching anything else in the switchboard. I have given AC input to the module. If you see closely, the node MC is turned on, and we still have the LED logic in the node MCU. So let's change the logic. Be careful while handling this module. I had wrapped the whole backside with an electrical tape. Now it is powered with AC. Be careful when handling this module. Okay, let's go to the logic edit. So we have this output and then light. Let's remove this part. We don't require this anymore. So in the relay module, the GPIO 0 is connected to the relay. So that's how relay module is designed. So we need to turn on and off GPI 0 to turn on and off the relay. There is this switch component in ESPHome that directly connects to a GPIO module and turn it on and off. Okay, let me paste the logic. This is the switch component which we can give the GPIO pin which you want to control, and we want that GPIO pin to be true. That is the initial state would be low. Yep, let's save this. We can validate the logic. Let's validate the logic. Everything looks good. So let's click on install and let's click on wirelessly. Okay, so the OTA update is successful. So let's go to the stop and let's go to visit. Okay, now if you see we have a motor switch here. So let me take the relay module into my hand. Let me on. So the relay is on now. The relay is off now. You can see there is a small indicator in the module when the relay is on. Okay, so the relay is on now and relay is off. You can also hear to relay switching sound. So yeah, the relay is working fine. So this module will go back in the switchboard of my motor switch. So that's it for this video. So we have completed like one part of the project, that is controlling the motor switch using a HTTP request. In the next part, we will see how to read the sensor reading and send a HTTP request to this node MCU from the node MC at tank side. If you didn't subscribe to the channel yet, please do a subscribe. Thank you. Bye bye.